Okay, we're going to start the next section of our unit. This is section 2.2. We're going to start talking about subsets. We're going to add some more notation for this chapter, so make sure you're ready for that. Let's first talk about what a subset is. It says that set A is a subset of set B, and it's expressed using this notation, so it kind of looks like a sideways U with a line underneath, if every element in set A is also an element in set B. So if every single thing in A is in B, then we say that A is a subset of B. Okay? We also have the notation is not a subset of, so you might see that. This one down here says that every set is a subset of itself. So I could say that A is a subset of A. Well, technically that's true because every element of A is also in A, right? Because they're the same exact thing. So any subset is a subset of itself. Let's do some examples and maybe it'll clarify a little bit more. Looking at example number 1, it asks us to write subset or not a subset in the blank to form a true statement. So looking at the first one, set A includes the elements 1, 3, 5, and 7, and set B includes elements 1, 3, 5, 7, 9, and 11. So if every element in set A is in set B, then A is a subset of B. So would you say that everything in A is also in B? Yeah, they both have a 1, 3, 5, and a 7. So we can say here that A is a subset of B because everything in A is in B. Now if you look at part B, it says set A is the set of all x's such that x is a letter in the word proof. So if you were writing this in roster method, it would be PROOF, right? This would be set A. Set B is the set of all y's such that y is a letter in the word roof. If you were writing it in roster method, it would be ROOF. So is every element in set A also in set B? No. Well, isn't there this extra P? So on this one, we would say that A is not a subset of B because everything in A is not in B. You have an extra letter in there. Now, what if I reverse that? What if I said, is B a subset of A? Well, then that would be true because every element in B is in A. So I could say B is a subset of A, but A is not a subset of B. All right, look at the next one. C says that set A is the set of all x's such that x is a day of the week. If we were writing it out in roster method, wouldn't that be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday? Well, set B says that we have a set that contains the elements Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So is set A a subset of B? Is every element of A in B? Well, to me, they're the exact same thing, so that's definitely a subset. Everything in A is also in set B. A is a subset of B. I've given you a couple other examples down here if you're confused on any of that. I have set A as A, B, and C, set B as A, B, C, C, B, and set B as A and B. And I have some statements down here to hopefully kind of give you some more examples and clarification. I could say that set A is a subset of B because everything in A is in B. You have an A, you have a B, you have a C, and so A is a subset of B. I could even say that B is a subset of A because technically isn't everything in this set, A, B, and C, also in set A? Remember, it doesn't matter about the repetition. As long as it has an A, a B, and a C, they have the same elements, then B is a subset of A. So even if there's repetition of the same letter, they still have the same elements. A is a subset of B, and B is a subset of A. We could also say that C is a subset of A because every element in C is also in A. We could say that C is a subset of B. Every element in C is in B. But A is not a subset of B because there's an extra letter, right? C. So A is not a subset of set C because A doesn't have everything C does. Has an extra one, right? And we could also say that B then is not a subset of C. B is not a subset of C. C is a subset of B, but B is not a subset of C because B has an extra element in it. Hopefully those extra examples clarified for you. All right, here's where it gets a little trickier. we're going to talk now about what we call proper subsets. Now, we have to make sure that it's a subset first. So we need to make sure that every element in A is in B. If that's true, then we could see if it's a proper subset. A proper subset says that set A is a proper subset of B, and now we use this symbol, so it looks similar to the subset just without a line, so it's just the sideways U. If set A is a subset of set B, and set B, A and B are not equal. So if everything in A is in B, then it's a subset. If they're not the same exact thing, then we call it a proper subset. Okay, let's do some examples. Look at number 2 with me. It says here, write subset or proper subset or both in the blank to form a true statement. So part A says A is a subset of all x's, A is a set of all x's such that X is a person and X lives in San Francisco. So A are all the people that live in San Francisco. B is a set of all x's such that X is a person and X lives in California. Well, if you live in San Francisco, do you live in California? Sure, right? Because San Francisco is in California. So I would say that A is a subset of B. Because everybody in San Francisco lives in California, all the elements of A are in B. Now, are they the same exact thing? Well, no. Aren't there extra people that live in California but don't necessarily live in San Francisco? So if you were to write them out in roster method, they wouldn't have the same exact elements. Every element in A would be in B, but B would have some extra. So we could actually say that this is not only a subset, it's a proper subset because they're not the same exact thing. Look at part B. Set A is the numbers 2, 4, 6, and 8. Set B is 2, 8, 4, and 6. Is every element of A in B? Well, yeah, I can say that it's a subset. Every element of A is in B, so it's a subset. Are they the same exact things? Yeah. So I wouldn't say that it's a proper subset. I would just say it's a subset because they're the same exact things. They're not different. They're the same exact. So we only use proper subset when they're not the same exact thing. So I would go ahead and keep that line underneath because I want you to know that they are equal. Okay? Check for subset first and then check for proper subset. This next little green box says a couple different things. It says an empty set is a subset of B. If I have nothing, I could say that it's a subset of any other set. I kind of use the analogy of a juice that has lots of different stuff in it, like orange, pineapple, banana juice, right? If I have orange, pineapple, banana, and I go and pour empty glass into it, it doesn't really change my juice, right? And so I can say that an empty set is a subset because it kind of contains, it won't like affect my juice, I guess I could say, right? And because they're not the same exact thing, we could say that an empty set is a proper subset of B. Okay? So if you look at example number 3, A is an empty set, and B is the set that contains 1, 2, 3, 4, and 5. So is A subset of B? Is every element of A also in B? Well, if you think about the juice, if I pour nothing into a 1, 2, 3, 4, or 5, have I changed it at all? Have I added anything to it? Well, no. And so then we can say, since I haven't added anything new or different, then I could say that it's a subset. Okay? Now, is it a proper subset? Are they the same exact things? No, they're a little bit different. So we could say it is a proper subset as well because they are not equal. So I could use both notations in this example. Kind of tricky. You should probably make sure that you do extra homework on that. If you're confused a little bit, do more similar problems to kind of get a hang of those two different ideas, subset and proper subset. Let me know if you need anything.